Hi, everyone. Today is August 17, 2023. I'm Swati Sehgal. I'm going to be hosting today's Kubernetes batch working group meeting. I just want to remind everyone that this meeting is recorded and to keep in mind the CNCF Code of Conduct. So we have Marcin here today with us, and he's going to be talking about multi-cluster dispatching, job dispatching in queue. So Marcin, over to you.
Hello, everyone. Welcome to this presentation. I'll be going through the couple of slides, and if you have any questions at every moment, please don't hesitate to interrupt me, ask your questions. Please don't wait until the very end. At the end, you will still be able to ask questions, but I would strongly prefer if you ask them during the presentation. Okay, so just a quick reminder of what is Q. Q is a project that we in this group we started, I know, a year and a bit ago. It's a job scheduler that for now has been mainly focusing on single cluster job admission and management. And in this presentation, we'll try to present an idea for the expansion of multi-queue towards multi-cluster environment. Okay. So let's look at what queue admission process looks right now. So in your cluster, once you install a queue, you create your workload. The workload could be a regular Kubernetes job, could be job set, could be MPI job, or something else with which queue has integration. From the job, we get pod requirements. So we know what pods will be created with this job, and we can check whether these pods fits into your quota or not. If currently there is not enough quota in the queue to which you assign the workload, we wait. And once the quota is enough, we admit the workload, and the workload starts. Queue has support for preemption for higher priority jobs. So if some workloads needs to be stopped in order or high priority job to be started, it is done during this admission process. Okay. And the basic quota checking increases the chances that the workload is started in full. Usually with batch processing, you don't want to start half of your pods. You prefer to start all of them, ideally at once, or don't start them at all. Quota checking gives you like a moderate guarantees regarding whether the workloads can be started or not. It doesn't look into free resources in the cluster. It doesn't look into what could possibly be provided with auto-scaling. It just checks whether one number is smaller or equal to the other number, and based on that, admits the workload. So the actual accuracy and performance of this quota checking and how much atomicity in starting your job you get depends on the quota value that you're supposed to set. Very big profit of this is that it works everywhere on-prem, on any cloud. It doesn't have any dependencies. You just need to provide a number, and this number is used to decide whether your workload should be started or not. However, that's not good for everyone. So ideally, we would like to have stronger guarantees that once we start the workload, the workload will actually start running and all of the pods will be scheduled. A single number cannot give this guarantee, so we need to expand queue admission process with some additional functionality. Basically, during the admission of a workload, we would like to perform some additional checks on top of regular quota checking. So first, once the workload is created, we check the quota. If quota is not permissive, so you don't have enough resources in the cluster currently, well, you wait. But as soon as the quota check is passed and you have enough resources, we would like to execute additional checks Once these additional checks pass, we will finally admit the workload. What could be these checks? For example, you could check whether in the last months the user used a lot of GPU's hours, and based on that, admit it or not. You could talk to your cloud provider and check whether the nodes for the workload that is just about to be admitted could be provided or not. Or you could check some other clusters, what they are doing, what's their status, what is the resources inside of them. So this two-phase admission process is a foundation for more advanced queue features. In our multi-cluster solution, we will focus on the two below. So capacity checking and talking to other clusters. About 1 month ago, on this batch working group, we presented a provisioning request API. This is an open source API that allows you to ask Cluster Autoscaler to provide a capacity for a particular set of pods, so a workload that you want to run. Cluster Autoscaler will only confirm the capacity request if it can be provided in full. The exact details of how the capacity is provided depends on the Cluster Autoscaler integration with individual cloud providers. However, the goal here is to ensure that the capacity is there before the workload is started. So either all resources are obtained at once or none. And using provisioning request strengthens the atomicity of the workload start. So we will not only be checking quota, we'll be talking to cloud provider and ensuring that the resources can actually be provided in full before we start the workload. Okay. Now, how we combine it with this functionality with talking to other cluster into multi-cluster solution. So we want to create a manager worker architecture. So one cluster will be running an instance of a queue with a controller that for each job that is being submitted to this cluster, it will talk to other clusters and create the very same definition of the job inside of them. Then these individual worker clusters will independently try to admit the workload. Hopefully, one of them will succeed. And once it succeeds, the management cluster will notice it and delete the job definition in the other cluster so that the only one cluster will proceed with the job execution. Inside of the worker cluster, queue may use provisioning requests to ensure that once admitting the workloads, the capacity will still be there. However, that's not a strong requirement. Queue can also work without provisioning requests and without talking to Cluster Autoscaler with weaker guarantees. Okay. What the user will configure. So with this additional checks configuration, the user will say that he wants to run additional check in the management cluster and wants his workloads that are sent to a particular queue to be created in a couple of other clusters. In a separate CRD, they will provide information how to establish connections with these clusters and how to create kube client in order to talk to them. However, from the user perspective, it will be relatively simple. They will be just sending a job definition to the management cluster to one of the queue. Queue will be sending job to other clusters. One of the clusters will admit, and in the management cluster, the job status will be reflected. So we'll be copying the status of the job running in one of the worker cluster to management cluster, so that the user can only look at the management cluster and get the full view of what is going on with their job. If they decide to terminate job at any moment, multi-queue controller will delete the job in the worker cluster and the job will be stopped. If for a reason where the job is started in multiple clusters because of some race condition occurs, one of the job will be stopped, the other one will continue to execute. This approach has a couple of pros. So there will be no new API for running jobs. It will work with whatever work in queue. So it will work with job, so it will work with job set, MPI, PyTorch job, array jobs, and all other integrations that we are adding to queue right now. So users will be running same binary and same functionality on both execution and management clusters. So things like preemption, quota borrowing will work on both levels. It will work with auto-scaling via provisioning requests and will work across regions, clouds, and on-prems. It doesn't have a strong dependency on any of the clouds, so it can run basically wherever Kubernetes is able to run. The cons, it doesn't address storage, so users will require to take care of the storage and possible data transfer on their own. The users will need to set up management cluster. This role could potentially be later shared with one of the worker clusters. They need to manually set up the authentication between management and execution clusters and create appropriate queues and namespace in all of the clusters, or use some additional tools to do it, I don't know, like GitOps or whatever. Okay, so this is the basic idea that we would like to implement in the queue, and we would kindly ask for your feedback, for your opinions, especially would like to learn whether it works for your solution, for your problems, whether you have some additional requirements for it to be used. Hopefully, the implementation will start in the next release of Q, so sometime September, October timeframe, but this all depends on your feedback and engagement. Okay, that's all from me. Any questions?
Hi, I have one. Have you considered looking into something like Karmada or OCM for to leverage some of those existing tools with Q?
Yes, we looked into Armada,
No, sorry, Karmada with a K.
Karmadan. Oh no, we looked into Armada. To be honest, I never heard about Karmada.
Yeah, no, because I mean, when I was thinking about multi-cluster, I noticed that there is kind of this concept of pluggability for how you actually deploy workloads to the different clusters. And some of the use cases I think we've gotten from users was around some clusters might have different, workloads installed on them. And so I was just curious, like I was looking at something like Open Cluster Manager. Looks like it has some kind of extensibility built in into the, I guess you would call it scheduling of multi-cluster. So I was just curious if you looked into like those projects for like a way, because I do see like like some requests for different kinds of extensibility and how you're dispatching workloads across different clusters.
No, so we haven't looked into that particular project. We look at other alternatives like Armada, like uh, multi-cluster job dispatcher. So these were the projects that we investigated. I will take a look at the one that you mentioned.
I think slightly differently to them, K Armadas or Karmada, which is harder to understand what you're saying. It's not necessarily for batch. It's more about just how do you get Kubernetes to act reliably across clusters. So I think it would have a higher chance of potentially removing that con of having to do storage and like other kind of networking things on your own. Like Karmada with the right settings and right configs might be able to help with that, which I think would be useful for people's use cases, right? Because everyone's going to want some kind of automatic sync rather than manual sync. So
I think this fits very well within our idea that Q is, for the most part, a specific controller with a specific role of scheduling. And for cluster management, and in this case, multi-cluster management, you can pair it with whatever technology suits you better. Like, yeah, Karmada, there are a few options. Uh, um, yeah, there are multiple multi-cluster administration tools that can be leveraged, and Q remains focused on just the scheduling.
And we don't require to change any of the system components for Q. So no extra scheduler, controller manager whatsoever. So in theory, it should be able to work with anything that you may have. I don't, should it be Antos, OpenShift, or whatever.
well, I think more what me and Kevin are getting at is I think like we totally get like the separation of concerns that Kubernetes is built on. So I think it's more that does that architecture that you've built in its current form work nicely with these multi-cluster managers is more what we're thinking in terms of if it doesn't work nicely, then can we do a very small change to make it work nicely? And I think that should be considered now rather than later. I think that's more what we're getting at rather than because like the architecture works. I might be surprised if it didn't, but I think that's more what we're getting at. Is it'd be cool to see if like what you think, because obviously if it's trying to put the pods in different clusters or something like that, right, that could be problematic.
So from the administrative point of view, you need to ensure that the roles are set correctly, that namespaces and queues are correctly synced across the clusters, that queue installation is more or less up to date in all of them. And the master cluster has ability to connect to all of them. So someone provides kube client definitions that could be picked up by multi-queue controller in order to contact the clusters. So multi-queue doesn't focus on addressing any of these problems. We hope that appropriate kube client config will appear miraculously on some directory to which you can point multi-queue, and it will be refreshed accordingly. And that with this connection, you will be able to execute the necessary stuff inside other clusters. Hopefully, if that's true and all of the configuration options are done, then the management tools should not get into way of multi-queue, because what it will be doing, it will be just creating jobs as any other users could do with a simple kubectl command. And it will watch its status. So as long as this management cluster has a way to establish connections and create jobs and monitor the status in the worker cluster, everything should be fine. So there are no other dependencies on individual clusters. It gets tricky once you try to deal with data. However, data is explicitly out of scope of it. We cannot provide solution that will automatically copy the data inside of Q.
Yeah, okay, great, thanks.
So in your architecture, would you consider like the different worker clusters for queue to have, I forgot what the term you call it, but like say like there's like job set or MPI on a worker cluster, and maybe on different worker clusters you have something like, well, I guess by default they'll all have job, or I guess we don't really know. I guess what I'm asking more is like a heterogeneous worker clusters where you have different controllers.
Yes, so whatever queue is integrated with would be supported in multi-queue architecture. The one requirement is that you can disable it somehow. I mean, the controller, not the CRD, in the management cluster, so it doesn't get into way with queue. So things like that have CRDs like MPI jobs, job set, Python jobs, array jobs, and others will work relatively easy. It would be a little bit tricky with regular Kubernetes job because Kubernetes doesn't provide a super easy way to disable job controller. In controller manager, you need to have admin permissions to the master in to disable it. However, we hope to resolve that problem soon. And
Yeah.
then whatever you have in the worker clusters will be supported if you want to run MPI jobs in one of cluster and array jobs in the other. Hopefully you will be able to do it either by picking the queue or with some additional controls that we could write in the queue itself.
Okay.
Any more questions?
Hey, Martin. I'm wondering if you've been able to give any more thought to the idea of at most once guarantee for a job or a pod in multi-queue. So,
Mm.
yeah.
Yeah, we can do it. So I talked with Alex before this meeting. He wanted to have at most one semantics. We could do it. We could just ensure that we delete jobs from other cluster before we start. We allow it in queue that's about to admit it. So it's not a big deal. It doesn't introduce any significant change in the architecture. Just job admission will get one additional step. So that could be done relatively easily.
That's great to hear. So I guess for everyone's benefit, the use case here is we would use something like this kind of in search for capacity, say for like very hard to acquire GPUs in some cloud vendor. So let's say we have an east and a central cluster. We would have the job submit to both of them, and whichever one could acquire the capacity first, we would want to run just there and not in both.
So here, just before the workload is admitted and when we do preemption, we'll just pause and let the master cluster confirm that it removed the job from all other clusters, and there is only one instance of it in one of the worker clusters, and only then we will admit it. So that's relatively easy to do it. It probably won't come in the very, very first alpha-ish release of multi-queue, but hopefully it will be added shortly after.
Thanks.
Do you have any other questions for Martin before we move on to the next topic? Sounds like we don't. Thank you, Martin, for the discussion. I wanted to discuss enhancements for Q 0.5. Aldo, do you want to share your screen?
Yes, if I can.
Yeah, sure. Okay. You should have co-host now.
Okay. Um, Let me know if you still hear my voice after I start sharing. Can you still hear me?
Yeah, we can.
Okay, perfect. Um, so yeah, I just wanted to give a quick heads up about the new requirements we came up with for the next release of Q, which should be targeting early October. So yeah, we would appreciate your feedback if you have any on the GitHub issues themselves. Let me just go quickly through them. A few of them, as you see, they're already finished. So we introduced the idea of partial admission, where you can start a job with a smaller size. And we did that by changing the parallelism in the job. But there are some use cases where you also have to change the number of completions. So we added the option to just keep them synchronized together, which is possible because we also added this supporting in upstream Kubernetes to change the number of completions of a job. So this should be useful for any tightly coupled parallel job. Some extensions to the coverage, wanted to increase support. The next topic is some metrics for cluster queue usage. Initially, when we introduced metrics for uh, for queue, there was a concern that if we added for certain fields, we could have an explosion on the number of possible values. So that was a concern. So we decided to make certain metrics optional. And usage of cluster queue is one of them. So if in your use case it's safe for you to add metrics or enable these metrics, you can do so and benefit from this extra visibility. The next enhancement is workload priority. So far in Q, we have been using pod priority as the signal for well, priority when queuing. And we find that it could be somewhat limiting because pod priority is tied to scheduler preemption, which might have effects that you don't desire. So we decided to just add an extra field that can control the priority of the workload um, independently from the pod priority, so the priority of the job. And with that, we're also making priority mutable. So if you have particular use cases where you want dynamic queuing, where the priority of a workload changes over time, you can do that. We are enabling that through by making the field mutable, but if there is like strong use cases that are widely useful, we might be able to accommodate them and make it part of the queue APIs to have these dynamic priorities. The next one is support for Kubeflow. We already had support for MPI job from Kubeflow for quite some time, but we were lacking all the other jobs, and we already made progress here. We just merged support for PyTorch job, but every other job is coming soon. TensorFlow, Paddle, so on and so forth. Yeah, we are making good progress here. The next one is this is an important feature to have some visibility in to be able to answer questions such as what's my position in the queue. This also has concerns in terms of scalability. So we try to be very cautious about adding this support. So yeah, you can read the details in the cap that should be linked in the issue. But yeah, we are offering this possibility of having the summary of the head of the queue, like which are the top, let's say, top 100 items in the queue. But that's configurable. You can disable it, or you can make it deeper or shallower according to your needs. And there is some follow-ups also in the cap that we're thinking of for the next release. But for now, we are doing it through status updates in the cluster queues. The next one might be interesting to some folks. We are adding support for plain pods or raw pods, pods that don't have a CRD backing them. This is some highly requested feature. We are starting with single pod support. That's the most common scenario where you just want to run one job, which is a pod. We also there should be a cap linked in the issue as well, where we are offering a design for groups of pods. Again, pods that are not backed by a CRD. We are trying not to make it, let's say, too good or like covering every possible scenario, because we still want people to use the job API, not raw pods or a CRD, because that gives us better control. But we are trying to still provide some support for groups of pods. So there is some API proposals there. The enhancement is still in discussion. So if you have any feedback, please do so. Please share. And the last one is preemption based on resource flavor order. Today, Q has kind of a strict, let's say, a strict policy for doing preemption. Basically, it will try not to preempt if it can borrow resources from other flavors. So let's say your first option is spot and your second option is on demand, and you require preemption to feed on spot. Sorry, let's put it the other way. You have first on demand, then spot. But to run on demand, you need to preempt. Sometimes that's acceptable, and sometimes it's not. Today, we don't preempt. We try to fit it in the next flavor, which would be spot. But if your workload is not, you would rather not run on spot, you might prefer to preempt on demand. So this feature is providing the flexibility to do your own policy, so that you can decide whether it makes more sense for you to preempt or to continue with the next flavor. And the same, we're doing the same for borrowing. Sometimes you're okay borrowing, or you might not be okay borrowing. So this API proposal gives you the flexibility. So that's all we have for the release 0.5. There are maybe a couple of ideas that were kicked out from 0.5 to keep it manageable. But as you can see, we already have quite a lot of features coming. So this is going to be, I think, a quite exciting release. But yes, as I was saying earlier, please do share your feedback. There is a few of them that, for example, 973, 168, and 976, 582, they all have a room for for feedback. So your feedback is welcome. That's all. Any questions? All right. I guess that's it. Thank you.
Thanks, Aldo. Thanks everyone for joining us today. See you in 2 weeks.